Well, class, this is the second part of the experiment on chapter 2. The first part of the chapter was on linear equations, kinematics, straight line motion, and that was in the horizontal direction, the x direction. This part is on motion going up and down. It's called vertical motion or projectile motion. Like you throw an object into the air, that would be a projectile in that particular case. The equations are very similar to what we had in the first part. Instead of x, we use y. So where this would have been x before, now it becomes y. Y sub x sub 0 is y sub 0. V sub 0 y instead of v sub 0 x. T, and a g is the acceleration due to gravity. Now gravity and acceleration, as long as you're close to the earth, g is about 22 miles per hour per second. That's how fast you would speed up falling. In the case of metric system, g comes out to be about 9.8 meters per second 9.8 meters per second squared. So instead of a, you put in g. T is the time. And going back over here, this one, I say y sub 0, that's your original height in meters. Y is the height after time t in meters, 5 seconds or 10 seconds. V sub 0 y, that's the original vertical velocity. You throw a ball in the air, throw it up at 25 meters per second, that would be the initial speed. V sub y, that's the vertical velocity after time t. So we'll be doing a problem in about a minute where the thing goes up and it reaches maximum height, it stops, and it comes back down again. G is the gravitational acceleration. So that would be A normally, but now we're going to be using 9.8 meters per second squared as long as you're close to the surface of the earth and your time is in seconds. Now what causes confusion here is this minus sign. And the reason we use the minus sign because on the way up, you're slowing down. You're decelerating. So we leave G alone. That's 9.8 meters per second squared. But you put a minus sign in because it's negative on the way up. Well, once it gets up to the top and it starts down again, now it's going accelerating downward, but downward would be the negative direction. Upward is the positive direction, downward is the negative direction. So to avoid confusion, we just leave a minus sign there to take care of the problems. This would be v sub y, the vertical velocity after a certain amount of time. V sub 0 y is initial. G is 9.8. And here's another one of our equations from before. It was v squared, v sub 0 squared, 2a y x minus x sub 0, and now we just make it y. And there's one more equation here that we don't need it for chapter 2, but we will need it for chapter 3. And that's for horizontal motion, like a projectile when you throw a ball at a certain angle. Now what I did was I went into the textbook, I found a homework problem from chapter 2, so on page 2-9, and it's number 13, it's one of your homework problems. A ball is thrown straight upward at 25 meters per second. So the initial speed is 25 meters per second. It reaches the top of this motion, it stops, so there's 0. It started out at ground level, which starts out at 0. We don't know how high it's going to go. That's one of the questions here for this problem. And we know that g is 9.8 meters per second squared, 9.8 meters per second squared. The time, we don't know how long it takes, but we do know when it gets to the top, the very top, it'll momentarily stop before it starts coming down again. And so at the top, the speed is 0 meters per second. Now we look at an equation to solve this problem. The first part of the problem was to find the time. Well, we did a problem like this before. We know this, we know that, and we know g. We know these three things. So the equation we used before was v is equal to v sub 0 plus a times t. So it's a very similar equation. Now top here though, the speed was 0. It started up with a speed of 25 meters per second plus 25 meters per second because it's going upward. G is 9.8 meters per second squared, and we're looking to find out the value of t. So we simplify the equation and we work it out, and we find out the time come out to be about 2.55 seconds. It took about 2.5 seconds to reach the top. Now if you want to figure out the height, and I don't think it asks for that in this problem though, but if you do want to figure out the height, what you would do is you'd use this equation. Again, very similar to the one we had at the beginning of chapter 2. We're looking for the maximum height. It starts out at 0. It started out at 25 meters per second. We now know it took 2.55 seconds to get up there to the top. 1/2, 9.8, that's the value of G, 2.55 meters, or 2.55 seconds squared. And you go through the calculation and you work it out, and it comes about to 31.9 meters. And that's helped with chapter 2. All right, we can stop right there.